How's everyone doing? Even though I can't see it, maybe just show yourself amongst yourself. Show thumbs up if you're doing awesome. Show thumbs down if you're like sleeping tired like me, and thumbs in the middle if you're just fine. Maybe I'll switch just to see you guys. This doesn't work well. Cool. Well, anyways, so that's what my yoga instructor likes to do before class, like show thumbs up, thumbs down, and thumbs in the middle. And what I like about it is that it's a good exercise for your wrist, I think. And I'll mention throughout, why. I'll mention throughout the yoga throughout my speech. So my name is Isaac. I have been an Ember developer for almost 2 years now. So I think it's my 2-year anniversary, maybe in 2 weeks now. So it's almost there. I'm still very new to web development. So I'm assuming that there are people like me who are also new to Ember. So maybe also again, raise your hand if you're new to Ember, 2 years or less. And then, although I can't see you, can you also raise your hand if you're a mentor to new developers? So I think it's both the mentors and the new developers who will keep Ember strong and innovative as we move to the year 2020. And if you think about it, that's just in 2 months, less than 2 months actually. So I feel like, we have a lot of bright future ahead of us, and I'm excited to be giving you this talk. So today I want to talk about 2 things that I love with passion. This is mathematics and writing tests. It's kind of funny. As an applied mathematician, I studied fracture mechanics, which is the study of how things break. And now as a web developer, I'm still studying how things break, especially on IE11 and Edge, the banes of our society. But joking aside, I want to talk about writing tests, especially for developers who are new to Ember like me, and for the mentors who are guiding them. As a new developer, one of the things you could do is poke around the app and describe what you saw. And if you think about it, that's exactly what writing tests is. The only question that remains is, how should you write tests? Are there best practices they can follow? And I'm here to tell you the answer is yes. Every one of you has the power to write tests like a mathematician. By the end of this talk, you will learn 5 simple rules I like to follow when I write tests. They are, number 1, if. Number 2, use common everyday words. 3, write less with theorems and new terms. 4, all your bases are belong to us. It's kind of a strange sentence, but let's go with it. And then last but not least is, a picture's worth 1,000 words. So I came up with these rules based on my experience of writing proofs in college and graduate school. See, when I was in college, I wrote proofs that I would now consider horrendous and abomination. I made plain wrong assumptions. The logic didn't follow. And oftentimes my proof worked for some cases, but not all like it's supposed to. Does this maybe sound like you in your tests? In college, I actually hated writing proofs. And sometimes I hated myself because I wasn't good at this like all the other mathematicians before me. It wasn't until I entered graduate school when I had to study countless proofs day and night and had to write many proofs in return that I began to see patterns, best practices, if you will, for writing proofs. And once I saw these patterns, each month I got better at writing proofs. And soon I was even able to teach others like how to write theirs. And when I look back upon this experience, I wish I'd known sooner in college how to write proofs, because I'm sure I would have been fantastic at it. I wish I'd had someone, a mentor, to show me how. That's why I give this talk today to you. If you are a new developer who perhaps feels inadequate when writing tests, I want you to know that you're not alone in how you feel. I was like you, that you can get better practice like I did. And if you are a mentor, I want you to think about what are some best practices that you can teach and how your mentees might feel when they write their tests. So with that said, let's get this show started. Rule number 1 is about making good assumptions. When mathematicians write proofs, they use conditional statements, also known as if-then statements, to tell a story. So for example, if it is snowing, then I can go skiing, right? So if-then statements allow mathematicians to connect different scenes to tell one cohesive story. And because I'm terrible at skiing, I'll probably get injured and have a crutch for a month or so. And I think that's a powerful thought, that writing tests is nothing more than telling somebody's story. So suppose that you have this user, when the user visits the homepage, they see this form where for sign up, right? The user filled out the form with ease, and the submit button was enabled. The user clicked on submit, and they're redirected to dashboard. Now they are in level 2, hoping to find the princess in yet another castle. So here's where things go wrong. And I was really hesitant. Like, I'm not sure if I want to do this exercise again. So I'll just tell you what happened. So to illustrate, this is what happened at EmberFest. So the day before EmberFest was my birthday. I turned 31, and I was close to midlife crisis. So to cheer me up, the audience, they sang happy birthday for me, and we were all happy afterwards. So this test, on the surface, it worked perfectly. I got personal with the audience saying happy birthday for me, and afterwards they were happy. The problem is, I lied to the audience. The day before, it wasn't my birthday, obviously. I was 31, and I may or may not be close to midlife crisis. So as you can see, not all assumptions were correct, yet they were able to sing happy birthday and feel happy. This example, although is contrived, it illustrates a problem that you'll often face when you write tests. You have to make assertions based on assumptions. But in reality, when your tests are running, not all of your assumptions may have happened. And to make matters worse, the reason for that, it may not be obvious, especially if you're new to Ember. So in my experience, I think there are 5 things that cause me to make wrong assumptions. So I'll explain what they are and how Ember can help us solve these problems. Keep in mind that these reasons are not at all obvious, and they deal with advanced topics such as state transitions. So if any of these are new, I don't want you to feel overwhelmed. What I want you to get out of it instead is that when your tests fail, don't be discouraged. They're actually an opportunity to take pause and ask yourself, are my assumptions correct? First, there are observers and computer properties. So as your app grows, it becomes hard to ensure that these are triggered at the right time and that all of your dependencies are listed and up to date. I think things will be better with Ember Octane because we have now async observers and track properties. But still, managing state is not an easy task, and it requires thoughtful design. Second is data. The form builder component that I use heavily relies on observers and two-way bindings. As a result, the data that I expect to have and what actually exists in Ember Data Store, they can be out of sync if I'm not careful. So in general, when you're designing components, please use data down, actions up. Third is unsettled state. Ember's tests run synchronously, one assertion after another, but Ember's test helpers aren't aware of all async operations that can happen in your app. If you animate elements or read files, things that take time, you want to make sure that your app has settled before making assertions. You can use Ember's wait for and wait until helpers to do so. Fourth is leaky tests, and I think these are a headache. So ideally, each of your tests runs in an isolated environment. So unfortunately, the assumptions made in one test, they can sneak into another if you're not careful with things like asyncs, global variables, mocks, and stuffs. And as a result, whether one test passes starts to depend on another test. And trying to debug this is really difficult. So the only solution, to my knowledge, the only solution here is prevention. Ember Qunit can find async leakage, while Ember Sign-On can prevent stub leakage for you. You can also use Ember Exam to randomize how the tests are run so you can identify leaks early. But that's it. Again, if the leaks already happen in your app, it's really hard to fix it. And then last but not least is permissions. As developers, we're used to writing code as an admin because we get to see all parts of the application. And as a result, we may end up biasing our tests, thinking that the user does also. So please write tests for non-admins too. You can use nested modules to easily set up and group tests for admins and tests for non-admins. So that was a lot for the first part, I think. So I want you to all take a deep breath. So I mentioned I've been doing yoga, and I've actually been doing that for about a year now. So as you might know, in yoga, people practice ujjayi breath. You close your mouth and make a guttural sound in your throat like this. I swear, it'll see you every time. Except if you're on a video call like I am right now, and you forget to turn on the mic, everyone in the room hears you just heaving. That happened to me in a meeting with the Ember Learning team, and the person had to point it out was none other than Tom Dale, and that was that's quite an embarrassing moment for me. Luckily, he was really nice about it. So speaking of video calls, rule number 2 is about how to communicate with others. Remember that by writing tests, you're telling somebody a story. You want to make sure that the other person can understand you easily. You can do so by using common everyday words. Here, common means convention. It's something that many people agree to, like Ember. And simple means, everyday means simple. It's something that many are familiar with. So when mathematicians write proofs, they use everyday words such as continuous and zero to tell their story. You'll be surprised that proofs aren't always about numbers and complex equations. There are words like continuous and zero. There are pictures, and there's always a story. Just like mathematicians, you can write tests using words that you use in your daily life. Thanks to add-ons like Ember test selectors, Ember page object, Q the DOM, and ChiDOM, your test can be easily understood by other developers. Mathematicians also follow a common language. So for example, the letter F often stands for a function, while brackets and parentheses indicate the domain of F, the input of the function. Thanks to a standard notation, mathematicians can easily understand each other no matter where they come from. When writing tests, I recommend that you create a standard that is both easy to remember and easy to test. For example, if you use Ember test selectors, always refer to links by data test link and buttons by data test button. To check data, you can use a name data test field in both edit and vmodes. You may have noticed that I've been using the label or ARIA label to identify these data test tags. I think this practice of identifying elements by what's visible on the screen nicely complements accessibility-driven testing. This is something that add-ons like semantic test helpers are trying to solve. Rule number 3 is to write less with theorems and new terms. Mathematicians are very much like us developers. They love to write proofs that are short and dry. Don't repeat yourself. Remember the statement. Mathematicians can prove this with a single line. Use the intermediate value theorem. That's it. If they're really ambitious, they'll just use IVT and call it a day. It sounds absurd, but it's actually a powerful idea that you can write short tests if you know that a part of your test is proven already. Short tests mean less code that you have to maintain later. That's a good thing. Mathematicians call what's already proven a theorem. We developers call it a test helper. So thanks to Ember's new testing API, you can write test helpers to describe what the user does. Just like that. So here, you write an ordinary function. It's an async function in this case to describe the fact that the user can fill out a form. Then you call this function in your test. Here, I'm using it in an acceptance test. Think of writing test helpers as extracting a part of your test code for reusability. Another test helper that I use every day is called Authenticate. It assigns the user the right permissions in my test. Given these two examples, can you now think of ways to refactor your test code? There's another way for mathematicians to write less. It's to create a new term to describe an idea that happens over and over in different contexts. For example, you'll see continuous functions everywhere in linear algebra, calculus, topology, optimization, and everyone's favorite, machine learning. To avoid having to write the word continuous each time, mathematicians introduced this C notation. Now they can write less, yet precisely tell their stories. When you write tests, you'll find that there are assertions that happen over and over, but QUnit-DOM or CHI-DOM doesn't provide the API out of the box. It simply can't satisfy all of your business logic. But not to worry, just like mathematicians who create new terms, you can create custom assertions. Here, the assertion is enabled hides the complexity of checking a button state. It's a simple example, but you can definitely get more ambitious by checking complex data structures, such as tables and D3 visualizations, arrays and trees. By creating good abstractions, you get to enjoy two benefits. One, you get to write short, meaningful tests. Again, short means maintainable. And two, others can write similar tests without having to know the technical details on day one. They get to be productive thanks to you. Rule number 4 is all your bases are belong to us. When mathematicians write proofs, they have to cover all possible cases, and often that's an infinite amount. With tests, however, you can't cover infinite cases. Otherwise, your tests, they would run forever. Instead, you can find a basis to guarantee that your app works for almost always in the fewest number of tests possible. So let's take a look at what a basis is. In mathematics, a basis refers to independent vectors that span the entire space. The keywords are independent and span. Span means to cover, like test coverage. You probably haven't heard of the term basis, but I bet that you're already familiar with the idea. Latitude and longitude are an example of a basis. These two coordinates are independent, and for every combination, you can find a unique location in space, which is infinite. For example, 1380 will take you to Chennai, where you are, and 30-97 to Austin, where I am right now. Just two numbers, 3 counting elevation to describe the infinite space. The RGB scheme is another example. There are infinitely many colors that we can imagine, but each color is a unique combination of 3 numbers, red, green, and blue. So for us, a basis means finding a small number of tests that can be considered building blocks. If you can prove that these building blocks work, then mathematics tells us that our app works no matter what the user does. And that's a powerful statement. Let's make this idea of a basis more concrete by looking at 3 examples. Example 1, suppose you're designing this page where the user sees data and can take 5 different actions: create, edit, delete, clone, and import. You want to prove in your application test that you'll always show the right data in the table. The problem is the user can take, there are infinitely many sequences of actions that the user can take. For example, the user can create a record, then delete another. They can also do maybe import, edit, followed by clone. These are just 2 examples out of infinitely many. There's no way you can write an application test for each and every possible sequence. But what if instead you guarantee that each action takes the user to the right state? When the user first visits the page, everything works and they're happy. When the user takes an action, you make sure that they return to the happy state where everything works. And that way, when the user exits the page, you know that everything is correct. The beauty of this approach is that now you only have to consider 5 test cases, 1 for each action. And you can be confident that your app will be in the right state when the user visits and exits the page. Example 2. Here is a component that I created to visualize LDOT filters. You can enter a filter here to understand its logical structure and edit the expression with confidence. I can also find errors and help you fix them. There are infinitely many expressions that an LDOT filter can take, but you can always break that expression into 4 basic types and 3 operations, 7 vectors to check. And the last example is a D3 component for visualizing a DSL, domain-specific language. You can interact with this graph to write your code in reverse. Again, there are infinitely many programs that you can write, but the graph, it always boils down to a few basic types. That's how I know that my D3 visualization is correct. So I hope that makes sense. I think it's the most abstract idea, but it's also the most powerful one that I have. So now, you learn several strategies to level up your testing. You have to make good assumptions, choose the right words, write short tests, and break down large problems into small ones. And here's the part where I have to ask, are you as overwhelmed as I am? I simply have to read my imaginary script, whereas you have to actually listen and learn, which is by far worse, I think. Well, the final role in yoga terms is Shavasana. It's a moment to wind down, reflect on your journey, and then wake up re-energized. One tragic thing about proofs and tests is that they ask us to be perfect. The things that we build are ambitious and complex, but if we make one mistake, a proof gets rejected by the math community, while an app faces vocal customers. It's a terrible feeling to have, I think, to constantly worry whether our tests in our app are good enough. So the last rule that I want to share, I want to ask you to let go of your worries and be okay with not being perfect. What you go for instead is incremental change. Each day, each sprint even, you work on writing better tests. The most important thing above all is to have fun, to enjoy what you do. So suppose you're designing a component that is complex. You're not sure how to write tests for it. So you can start out with the most simple test, assert OK true. Even this one line offers valid information, namely that your component won't blow up in your app just by existing. That's a good thing to guarantee. And similarly, if you're working on a complex page, you don't have to write thorough application tests right away. You can use Percy or Backstop to take visual snapshots while they gradually introduce written tests. It feels counterintuitive, doesn't it? That visual snapshots are as good as written tests. Let's take a look at what mathematicians do one more time. I bet that before, this statement that meant very little to you because you didn't understand the words. Am I right? Here's the same statement in drawing. From this picture, it's clear that if my function is continuous, is positive on one end and negative on the other, it must equal to 0 somewhere in between. That's all the statement said. Furthermore, from this picture, we can imagine a powerful technique called bisection method. It's how get bisect works, if you ever use that one. Let me show you one more example to illustrate the pictures are powerful. I'll prove to you that there are as many numbers between 0 and 1 as there are between minus infinity and plus infinity, all numbers. It's a mind-blowing fact about infinity that a part can have the same size as a whole. So this green line, it represents all numbers between 0 and 1. Each number is a point on the line. From the center, I'm going to draw a semicircle. These dotted lines show that there's many points on the green line as there are on the blue line. Do you agree with that? From the center to each point in the circle, I can draw a straight line and stop at the bottom. Just like before, these dotted lines show that there's many points on the blue line as there are on the bottom green line. And notice that the bottom green line goes to infinity in both directions. Therefore, you can find as many numbers between 0 and 1 as you can between minus infinity and plus infinity. Isn't that simple? Now try to imagine having to prove that using using complex equations. I don't think you would enjoy it. But with pictures, this is very simple. So let's go over the rules once more. 1. Writing tests is nothing more than telling someone a story. You describe what happens to a character in the beginning and what happens to them at the end. Please check whether your assumptions are met in your tests. 2. To tell stories effectively, you want to use words that others can easily understand. Come up with a convention that you and your team would love to use every day. 3. Thanks to Ember's new testing API, you can create test helpers and custom assertions to write less code. You can write short, meaningful tests and help others be productive. 4. When you face a large problem, see if you can break it down into smaller ones. In particular, if you can find independent vectors that span the entire problem, you can guarantee that your app works almost always. And finally, 5. It's okay not to be perfect. Be happy with who you are today and whom you can be tomorrow. The most important thing above all is to have fun, to enjoy writing tests. So I want to close out by sharing a quote that I miss dearly. To me, this quote is about continuous learning and not giving up when things are hard. It's by a poet named T.S. Eliot, and it goes like this. We shall not cease from exploration, and the end of all our exploring will be to arrive where we started and know the place for the first time. So thank you very much for listening. If you'd like to know more about me, feel free to reach out on LinkedIn and Discord at IJLE2. Thanks again.